notes? Good. This is exponential equations / differential equation part 2. It goes a little something like this. Let's go back to, actually, before we do that, this, by the time I'm done with you, that should mean something. You should say, whoa, that's big, that's important. That's like dy dt equals ky, and that still probably doesn't mean anything to you. Or dA dt equals ka, and that doesn't mean anything to you, but it will. All right, now, back to pre-algebra. Here we go. Joe starts with $10 and earns 10% simple interest every year. Is it possible to find an account that actually pays you 10% simple interest? If you find one, please let me know, because that's freaking amazing. All right, that's ridiculous. And no, does the stock market pay on average about 10%?
I have absolutely no clue.
Over the 100-year history or so, the last 100 years, on average, the stock market does grow by 10% a year. Does that mean 10% interest?
I don't know.
No, stock market isn't interest. What is it? It's growth. Okay, so what's the difference between a bank giving you 10% per year and the stock market on average growing 10% per year?
Costs more than 10%.
I don't know. What is that?
I don't know how it works. If you go to the bank and they say they're giving you 10%, are you getting 10% guaranteed?
Yeah.
Yes. When I say the stock market grows 10% per year, is that guaranteed this year it's going to grow 10%? No, that's on average over 100 years. The stock market grows 10% over a year. But that's not guaranteed. The last 3 days, the stock market plunged 7%. So it's about risk, and the stock market is not guaranteed at all. Now that said, if you're in it for the long haul, can you count on it approaching that? Yes, but that's why you don't do stocks for the short haul. Joe starts at a year at $10. If he's getting simple interest of 10%, which I made 10% so we can calculate mentally, what interest does he earn in the first year? $1. What does he end the year with? What does he start year 2 with? And yet, despite the fact he has $11 in his account, it's simple interest. So how much interest does he earn the second year? $1, because it's not interest on interest, which is what compound interest is. Yeah. So you end with $12 the second year. Despite the fact you have 12, you still earn $1, putting you at 13. Now let's consider how that amount changes with time. Starting at $10, in 1 year it goes up $1. In 2 years it goes up another $1. In 3 years it goes up another $1. When the rate is always the same, what kind of growth do we have? Linear. This is linear growth. The rate of change is constant. All right, now consider compound though. Lou starts the year with $10. How much interest does he earn in the first year? $1. So far it's the same. But the second year, instead of earning interest on the original amount, he earns interest on interest. So how much interest the second year? $1. Putting you at what at the end of the year? So you could say he earned 10 cents of interest on interest, yeah? All right, so 12.1, 10% of that is 1.21. What is the end? 2 years with, sorry. 13.31. He earns not only $3 in interest, but 31 cents of interest on interest. And so $3.31 total. Now what makes this change at a varying rate is that the growth rate depends on the amount in the account. Now that's actually pretty doggone rare. Usually the growth rate depends on the independent variable. So your growth rate would depend on time, what the time is. But in compound interest, it is more common that the growth rate in the amount depends on the amount itself. This is revolutionary, very different. The fact that the growth rate of the amount depends on the amount itself, not t. All right? Now, getting into some calculus then, if I take that idea, the amount grows at a rate proportional to the amount itself, and throw a little calculus at it, then I want to get an amount equation, not a growth equation. So how do I get an amount equation, not a change?
It's on one side.
Yeah, so we're going to isolate, what are we going to do? Say it again. Not isolate A, we're going to separate the variables. So A is on one side and T is on one side. Separate the variables is what it's called, and that's important vocabulary. Separate the variables. And then we will integrate. Natural log of absolute value of A is KT plus C, yeah? K is a constant, relates to the interest, but it's not the interest. Now, consider then the initial condition. I'm going to do a general initial condition. At time equals 0, the amount can be thought of as the initial amount, yeah? Now, if I put that case in, then I get natural log of A initial equals 0 plus C. C looks like it's natural log of the absolute value of A initial. You follow? Back to the equation we go. Natural log of the absolute value of A equals KT plus natural log of the absolute value of A initial. And I put my C in. You follow? Now I want an amount equation, so I'm going to solve for A. What should I do first? Exponentiate. When I exponentiate the right side, is it exponentiate each or exponentiate all? All. So I get absolute value of A equals e to the KT plus natural log of A initial. So far, so good?
Familiar.
It should look familiar. Now, we said yesterday that e to the A plus B is equal to e to the A times e to the B, right? And so this side is equal to e to the KT times e to the log of A initial, which is just absolute value of A initial, which I'll put in front.
Oh my gosh, it's
You
not
follow?
equation.
If I throw out the absolute value by saying plus or minus, then I get this. Now, if you assume the amount is positive, then the absolute value, the plus or minus, aren't necessary. And you get the equation for exponential growth. That idea, this differential equation, where is it? There it is. Okay, this differential equation is the most famous differential equation of all because that's where exponential growth comes from. Right there. Okay? Now, it is very important that you, first of all, connect those two ideas. That differential equation yields that equation so that you don't have to do this every time. If I get dA dt equals 3a, oh, boom, that's exponential growth with a k of 3. If I get dy dt equals 2a, or 2y, excuse me, oh, boom, exponential growth with a k of 2. If I saw a rather weird notation, but it is the same, y prime equals 0.02 y, exponential growth with a k of 0.02. You with me? Now, when you see that statement, that amount changes in a rate proportional to the amount, you should understand that that is equivalent to exponential growth and avoid all the middle stuff. So now, consider here this pretty common for response or multiple choice. So they say differential equation is df dt equals kf. And right away my eyes light up because that is the rate of change in f relating to f itself and tells me exponential growth. And so that implies right there that f is f initial e to the kt. The variable could change from problem to problem. It might be y, it might be p, it might be a, it might be k. In this case, it's f. That's the same idea. You follow? Now with that then, it's pre-calculus time. How do I find k? Actually, you do it. You should be able to do it. Try it on your own.
I don't.
I just realized these have been on the homework, and this is why they were on.
I literally was never ever gonna be 12.
So you just need to. I gotta put that in my calculator.
Something like natural log of 2/3 over 16? Okay, I don't know what chance it is. Okay. All right, you following me so far? I know I'm going fast, but I have a lot to go. Pause for a second, are we good so far? Okay, go on to the second idea then. Try the first one. Given that differential equation and an initial amount, give me, without integrating obviously, the exponential equation. So what's my equation? Give me an equation. A equals e to the 0.03t. We good? Okay, try a different direction. Make sure you use the variables given in the problem. Don't just universally use A. Okay, what's your equation? Y dt equals 3y. Okay, there should be a match between dy dt and the variable in the equation. And last but not least, if the p dt is negative 1.2, p, I don't even know if I need that, do I?
No.
Because to find initial, I need to look here. So what is it?
13.
All right. We'll go to the ones on the back of the homework in a second, but flip that over, please. Say it again. It should be P initial. Sorry, good call. Thank you. My bad. Okay, here we go. So there really are three unbelievably super famous differential equations. The first one is dA dt equals Ka. Exponential growth is the most famous differential equation. There are two slightly less famous but also important. There's what's called logistic growth, which is, for those of you in AP Bio, you deal with logistic growth all the time. So if I put bunnies into that field, they would grow exponentially for a while, but not forever. Why not? Carrying capacity. Now that idea of carrying capacity, that means exponential growth for a while, but up to a point, that's logistic. Now that's typically a count 2 differential equation. Then there is Newton's law of cooling, which is what I'm tackling here. This is not on the AP test, but it is commonly taught in college Calc 1 courses, so I want you to see it. So it goes a little something like this. If you take a lasagna, okay, if you take a lasagna out of a 400-degree oven and place it on the counter of a 70-degree room, say, okay, what will happen to the temperature of the lasagna? It'll go down. When will it decrease the fastest? At the beginning. Why? Okay, but why does it grow fastest at the beginning? Why not at the end? Greatest difference. Perfect. That's exactly what I want you to say. Okay, the growth rate or decay rate depends most on the difference between the two extremes. And when the difference is great, the growth rate or decay rate is great. That's what this is saying. The difference, this should be a B right there, sorry. Okay, the difference between the temperature of a body and the ambient temperature of the room directly relates to the change in the temperature of the body. So in this case, TA is the ambient temperature of the room, that's constant. Although I'm told physics people say the temperature of the room will change a little bit by putting a lasagna in the room again.
Ours it's like not.
Over there as well. This is not O. This should be B.
Yeah.
Like on all of it, it's
It is.
yeah, for all of it, all the way down.
They're O's. Can I not change this?
Wait.
Oh, all this changes.
Yeah, so I think it's fine.
No, I don't change them all to B's because people got confused. They thought that meant initial temperature, and that is not what it means. Okay, so change them all to B's. I was using T sub O for temperature of the object, but after I finished, obviously after I made my copies, I thought they're going to think that's initial. That's not. Okay, so temperature of the body at time. All right. Now, if the body is warmer than the room, like the lasagna is warmer than the room, then what's the temperature of the body graph going to look like over time? It'll decay and concave up or concave down? Concave down because the rate of change is greatest at the start and then the slope evens out. Does it go to zero?
Hopefully not.
Oh, concave up. I said concave down, didn't I? Sorry, it's concave up, and it doesn't go to zero because it approaches the temperature of the room, in this case, say the 70 in the example I gave you, yeah? All right. If that's the case, then is dt positive or negative? The temperature of the body, rate of change, is it positive or negative? It's negative because the temperature is decreasing. Now, based on that equation there, would K be positive or negative? Negative. I know this is supposed to be negative. Don't know about this. If the body is warmer than the room, then what's T sub B minus T sub A? It's positive. So K has to be the source of the negative. Now that makes sense. So when it's decaying, K is negative. Negative exponent. We'll see. All right? If the body is cooler, for example, I took the body out of the freezer and put it in the room, then it would increase, approaching the temperature of the room, the ambient temperature of the room. And in that case, the rate is changing at a positive, and in that case, K must be positive. Okay.
Wait, wouldn't it be negative? Because the thing is
TB minus TA would be negative. So you'd have to have another negative.
Oh, what the freak? Let me think about that. This is negative, and so K needs to be negative. To get a positive, you're right. Why didn't I catch that before? Good job. Way to think critically. Okay, good call. Yes?
So it keeps saying body, but is this like apply it like human?
Yes, it is. Okay, so when you do all that CSI stuff, you know, when they say, oh, based on the temperature of this, he's been dead for 2 hours.
Not like a live.
That's this. No,
No, a dead guy.
no.
But like a live body.
No, a live body fluctuates temperature, so it does not pertain to a live body.
Yeah, we do homeostasis.
Okay, that's a good point. I didn't even think about that. Yeah, but if you take DiffQ, you'll do the body's temperature is this. How long has he been dead? That's tough. What do you think is rolled into the K? It looks like the rate of change depends on the gap between the room and the body. But what else would go into the rate at which the body changes, or the lasagna changes, or whatever? I can think of two. Give me one. Surface area, yeah. Imagine a lasagna that was like a brick and super thick versus it was really wide. What would cool faster? Yeah, the surface area matters. Surface area of the body, or exposed surface area, matters a lot. And then what else? Yes?
I have a question. Is K ever going to be positive then?
Apparently not. They did not say anything about it. They were, in last class, they're very much they just write it down. Okay? So good job, third grade. What else? The body itself, the nature of the body itself, and how the body cools itself. You know, something might cool faster than another material. So that also would go into it. Now, consider then, if I give you a sample problem. An object is pulled from a 300-degree oven and placed in a 70-degree room. Now, if the object was in a 300-degree oven, then what's the initial temperature of the object? It's the same as that 300 degrees, yeah? Assuming it had been in there long enough to reach equilibrium. After 10 minutes, bless you, the object has reached a temperature of 200 degrees. Based on that, you should be able to give me an equation for the temperature of the object. Now, let's start with Newton's law of cooling. The temperature of the body, rate of change, is a constant, which we'll find, times the difference between the temperature of the body and the temperature of the room. Now, does the temperature of the body go in constant, or is it going to change over the course of the problem? Okay, so it needs to stay T sub B, but what about the temperature of the room? That's going to stay the same. So we're going to put 70 in there. All right. All right. Now our goal is to get a temperature equation, and so to get rid of the differential equation, what do? But first, separate the variables. So if we separate the variables, we might do it this way. K could go either way, but it's much easier if you leave it on the right. And so let's integrate that. What is the antiderivative of the left? Natural log of the absolute value of T sub B minus 70. That minus 70, I guess you could use sub it, but I only use sub this in a case where I have a coefficient. Thank you. The added constant wouldn't be a big deal. What about the right side derivative, antiderivative? KT plus C. All right, now.
Is that a poorly written K or is that a T?
That's a K.
For the integral. Oh, I thought
That's a T. That's a K. Okay? That's a K. All right. Now then, you're going to find the C using the time 0 case. At time equals 0, the temperature of the body is 300. Now, based on that, I would have natural log of 300 minus 70 equals C. So C is the natural log of 230. Once you know there's a positive in there, you don't have to keep the absolute value. It's not doing any good. Okay? Now let's go back and say, all right, natural log of T sub B minus 70 equals KT plus log of 230. Are you down? Now you actually have two constants. Yes, question?
So I'm kind of confused when you use natural log and then you like move the equation to a numerator and it's negative bottom.
It is, so the only time, let's just go with exponents. Negative 2, x to the negative 3, x to the negative 1.1. All of those kind of have a power rule flavor to them. But the only one that's actually a log is this one. Anytime it's natural log, it has to be the fact that it is 1 over x to the first. If it is 1 over x to the first, it's natural log. Every other case, power rule. So this is, x to the negative 2 over negative 2, or x to the negative 1 over negative 1. X to the negative 0.1 over negative 0.8. Okay? So the exponent has to be 1, exactly nothing else. Good question, because I've seen that error a lot. Now, we're going to need to also find k, yay? So now we're going to go off to the side and find k. What's another condition with which I can find k? 200 after 10. So the natural log of 200 minus 70 equals 10k plus log of 230. So this would be log of 130 minus log of 230, all divided by 10, right? So in its simplest possible form, K is, use the log rules for me.
Oh wait, you divided, 13 over 23.
13 over 23 over 10 for K. See? All right. Back we go to finish up our equation. Natural log of t sub b minus 70 equals, do you want to write that for K or just keep calling it K and put it in later?
Put it in there.
Call it K, it's less writing. Okay, so KT plus log of 230, but now I really do know K. All right, so now what do I do?
Exponentiate.
You exponentiate. So absolute value of t sub b minus 70 equals e to the kt plus log of 230. But what is that side cleaned up? 230 e to the kt. When we use that exponential work of e to the a plus b is the same as e to the a times e to the b. And then the log exponent inverse again. You see where 230 is coming from? All right. So, how about the absolute value? What happened? Plus or minus 230 e to the kt. So t sub b is 70 plus or minus 230 e to the kt. And at some point then we have to choose. What do we choose in order for time 0 to result in a temperature of 300? What do we choose? We must choose positive. So t sub b is 70 plus 230 e to the, I guess I'll throw in my k here. That's a lot. There you go. Does that make some sense? Cool. Would you get out yesterday's homework, please, and turn to the back? You probably had a great deal of difficulty on 3 and 4 because I haven't taught you that yet. But now it'll be easy. 3 on the back of 88A. That was called, or is it just called 88? It looks for a problem. It looks like a problem set in the front, I think. Yeah. But on the back, in the middle, there's 3 and 4. Would you do 3 and 4, please, to see if you understood today's lesson?
Can we turn in 87?
No, we're going to go through these.
Remember that beta this year, beta 15 from algebra.
What'd you get for A? B? you are really good, you have superior number sense, you could actually do the second problem without a calculator and without actually even knowing any calculus. What'd you get? Hey, how could you do this mentally? In 3 months, it grows by a factor of what? No, I didn't say a sum. I said a factor. What do you multiply it by? Third? Grows by a third or grows by a factor of?
4/3.
That's 4/3. 3/2. It grows by a factor of 1.5. Yeah? It grows by a half, so it grows by a factor of 1.5. Yay?
Yeah.
Okay? Now notice they're asking you about another 3 months. So it'll grow by another factor of 1.5. 9 times 1.5 is 13.5. That said, if you did it exponentially, hopefully it works out something like that. And there you go. All right. The AP test. It was harder, but probably wasn't this harder. I got a lot of fall off here. Most of you are probably still in good territory for your total score on pace for a 5 thing. But this part here alone, definitely not awesome.
Phones and backpacks. There's be a lot of and they got above 50%.
Okay. So, first about the scores. If your percent, which should be right in the middle of your paper, is 82.5 or above, you're a very strong 5 and you got an A on the test. If your score percent rather is between 65 and 82.5%, you're still on pace for a 5 on this piece. Give you a B on the test. If you are between 54% and 65%, for this part, you are on pace for a 4 on the AP test, and I gave you a C for the actual score in the grade book. 44% to 54%, you're on pace for a 3 on the AP test on this part. Give you a D on the test, and percent score, if your percent is below 44%, you need to get on your game a little bit and be more active in getting home. All right, now that said, let's go over it and actually learn the math, shall we?
We shall.
Number 1, for the first problem. 5, 10, 13, 15, 45 people took this. 15 people missed this. That's a third. That is not okay. How do you do that problem? Yeah, that's useless. You should be able to use it. 1/3 of the people should not make an error in use it. That's ridiculous. Okay, that is a major skill. One should not have been missed. Number 2 was harder. I expected I was hopefully looking at about half the people getting this right, and let's see, 15 is about half the people missed it. So, some of these, I definitely feel like 2 of these answers should not have been chosen. They should have been excluded. Is it true that as x goes to 1, f approaches 0? Yeah, if you understand the idea of a limit, that it's an approach, not that dot, that means nothing, then you should know that that is true. Likewise, as g approaches 2, the one-sided limits being different definitely means that that limit doesn't exist. That's definitely true. Now, a lot of people chose badly on C, and I could definitely see this. It's because they looked at the back end. If you go to 1 of g plus 1, isn't that same as g goes to 1, g is going to 2? And it feels like that one-sided limits are different. That feels like that should also not exist, and that should be true, yeah? Well, what's the other part to it? Yeah, the f. What does the f do? As g does its thing, what does f do as x goes to 1? It zeroes it out. And so will they be the same on both sides? They will, because f is zeroing it out. It will be the same on both sides. And if it's the same on both sides, does the limit exist? It does. This is false, okay? And then this is true as x goes to 1, this would be f of 2, which is fine. And g goes to 1 is fine, so that's true. So you would choose C. Now those questions tend to be confusing. Besides the calculus level, there's the test strategy level, tends to get people. 25, I guess I need to warn you, to be fair, if I see this on the next test, h prime is f prime g prime, you and I are going outside. We are going to fight. That's insane. How could you, I mean, you've been doing the product rules since September 1st week. How can that still be missed? How? Okay, that cannot be missed. This also was hard. I expected this to go badly. I expected about half success, and yet 45 people, 5, 10, 15, 20, 25, 29, 32 people missed this. More than 2/3 of the people missed this. It was hard, but not that hard. The top flight of you definitely should have nailed it. As x goes to infinity, I agree the top is a little confusing because it feels like log and e should cancel out, right? And yet, there's more. So these don't really cancel out. This is more powerful than log. This does get big. The bottom obviously gets big. Along the same lines as that, if I see you treating infinities like numbers and say, oh, that's ridiculous. Come on, that's ridiculous. They're not numbers, they're concepts. And so that idea is ridiculous. What must you use? Yeah, you have to use L'Hopital. If you took the derivatives properly, then it is 3. Sure. So the limit there is actually a technique that I use that I don't know if I've ever taught you, but it was e to the 3x plus 1 and 3 to the 3x, plus x, excuse me. So there's the log derivative. Do you agree?
Yeah.
By chain rule. Over 1. Okay? Now, if you got that far, I'm pleased, but then you had a hard time evaluating that limit.
Oh, just because then you take
Now, there's 2 ways to do this problem from here. One school of thought would be, you could do end behavior, yes, and that works. One school of thought is you say, if you simplify this down, isn't this 3 plus 1 over e to the 3x over 1 plus x over e to the 3x? And doesn't that go to 3 plus 0 over 1 plus 0? That's one way to get it. End behavior is one way to get it. Another way to do it is to say, well, shoot, that's still indeterminate. Could you do L'Hopital again? You could. You would get 9e to the 3x over 3e to the 3x plus 1. And you might still say, well, it's still got the 1. If you took enough derivatives, eventually everything else but the e's would drop out and you would still see 3. Okay? The easiest way to do it, though, is just to use end behavior. Right? 27, some of you fell into the classic rookie trap. You bit on the wrong answer. So let's go with 1. Is f continuous? Why? It's different. The derivative exists everywhere. If the derivative exists everywhere, there's no breaks, there's no holes, then it's differentiable. If it's differentiable, it's continuous. So that is definitely true. 1 is true. 2, f is decreasing on the open interval. Well, obviously, yes, it's decreasing, right? No. This is the graph of f prime, people. If you're thinking, yep, decreasing, maybe you should read for an actual subject. F is decreasing. That's not f. That's f prime. So to say yes on 2 is ridiculous. Okay? And then this is false. And that's because if f prime is positive here, it's definitely not increasing on the whole interval. And last but not least, f is concave down. Well, I think you'll agree that f prime is decreasing, which means the derivative of f prime, which is f double, is negative. And if f double is negative, then f is, so that's a yes. It is C. The last one on that page, I felt like 2 of these should have been easily eliminated, and then most people chose, I had 20 people choose D, and this actually is a hard question because of that. But I think we can definitely rule out B and C. It says it has no vertical asymptotes. So doesn't that mean there should be no zeros in the denominator? These are out because of that. They have zeros in the denominator. They can't be. No chance. Okay? Now this is hard here because as x goes to negative infinity and x goes to positive infinity, these behave differently. As x goes to negative infinity, this then becomes 1 over e to the infinity. As x goes to negative infinity, this guy goes to 0, and therefore overall, that has a horizontal asymptote at positive 1. But as x goes to positive infinity, this is 1 divided by huge, that goes to 0. And so it has 2 horizontal asymptotes. That's rough, but that's out. It is A, it's classic. All right, backside. It was, if I were your English teacher or not your math teacher, I would have actually got a good chuckle out of seeing you try and draw this. I thought I could actually see on your paper this wacky isosceles, right? Trying, wait a second, isosceles looks like this, but how do I make a right angle? But if that's a right angle, then this has to be a right angle, so it has to look like this. Is there no triangle? What? Is this a trick question? Well, I guess they were thinking you would maybe make the right angle first and say, oh, the isosceles ones must be there. What the freaking heck? Are you trying to make the hypotenuse one of the equal sides? How? How? I just don't, whatever. That said, you didn't even need a I mean, you could just take the derivative. SDT, they gave you what you needed to plug and charge.
Wait,
That's it. You didn't need a picture at all. I don't even know.
Can you do a couple more steps from that?
Oh, that's why it was hard. Okay, so you weren't as bad as I thought. That's right. All right. So you're right. There was a secondary relationship. This one's harder than I should give you a little props. All right. So I guess I was just lost in the laughter. All right. So I think you'll agree that the area is given, yeah?
Yeah.
And you know the side is root 32, but that only gives you the length of a side change, yeah? That's the rate of change of the side. So how do I get the rate at which the hypotenuse changes? Another relationship. Side squared plus side squared equals hypotenuse squared, or 2s squared equals hypotenuse squared, or if you like, s equals,
S squared equals 32.
actually h equals square root of 2s, yeah? So dh dt is square root of 2 ds dt. Okay, and not many people, I only had one person miss number 5. I assume they were having a bad day. I hope. Okay, and then last but not least, this. You shouldn't have an easy 3 here. I feel like A was doable. You're doing area, which you could use X or Y. A few people used Y, and it was fine. Most people used X. It's upper minus lower. Upper is the square root graph of the lines. Square root graph. Okay, there's 1 point. That was the first one you see in your score. The second point was for the antiderivative. 2/3 x to the 3/2 minus x squared over 6. That's 1 point for the antiderivatives. Can I give you a little piece of advice from a guy that's not as calculator dependent, please? When you evaluate this, it is foolishness to cube first.
Why would you do that?
Why would you cube first? You're going to get 729. Then you got to square root 729. I had people cube 9, get 729, think, I'm supposed to do the square root of 729 without a calculator? No, you're not. You should square root first and call it 3, and then cube that. Make it smaller first, then bigger. Don't cube it first. That's terrible. Okay? It's 2/3 times 27, and go from there. The region revolved. If you use x, you should have washers. So the first point was, do you have pi squared minus squared? Do you understand how to find washers? Do you have that basic idea for washers? The second point is for, do you have the details right? The upper R, or big R, is the square root. The little r is the line. And the bounds are 0 to 9. That was the second point. And then the third point was, did you simplify this? Well, what's x over 3 all squared? Is it x squared over 3? It's x squared over 9. All of it is squared. And then the last is, actually not the last, antiderivative, evaluate, and simplify. All right, 27 pi over 2 is your answer there. Most of it was the setup. 2 points for the setup, 1 point for the carry through. Last but not least, the maximum vertical distance. Oh, goodness. So I had a number of people fail to read carefully for this really key word. Vertical distance. So it's vertical distance. Now, that said, you can still get there. If you went here, which I had many people do, x2 minus x1 squared plus y2 minus y1 squared. I don't feel like this is necessary if you're reading carefully, but let's go with it. If it's vertical distance, then I mean the distance vertically between the two. What do you know about the difference between the x's? You're moving vertical, so the x's don't matter. The difference between the x's is a big fat 0. And therefore, you're saying the difference between the square root of the y squared, or just the difference between the y's. Go figure. The vertical distance would be the difference between the y's.
That's crazy.
Who would have thought? Okay?
Good morning, Dublin Jaguars. Please rise to the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic rule, with liberty and justice for all.
Okay, you still haven't earned a point yet. The first point was for finding d prime and setting it equal to 0.
Up to their numbers to 35. There are 10 spots that are not having 7 hours today. Also, if you're signed up for Diversity Club, please approach the
Okay,
counselor.
like that. Oops, sorry, 1/6.
Today for a rousing game of Jeopardy! If you
1/3.
are a part of Boys and
You with
Girls
me?
Teams, you are expected to attend.
Second point was for solving, that's 9/4.
Has invited a special guest who's battling cancer. He will be
The last point was for absolute value, absolute or extreme values.
dangerous to the south. The Colorado State Football Youth Academy is accepting applications until March 22nd. Cadets will become familiar with the basic elements of the academy through a demanding daily training schedule.
0.
Limited to 45 participants selected throughout the state. The academy will be held July 19th through 25th, and the cost is free. Stop by counseling for the details.
Force maybe?
Do you have a passion for music, or have you thought of ever starting your own band? The 2020 Goodbye Challenge is a battle of the bands competition.
Now, if you said, hey, I said 4/3. If you said 4/3 without doing it in calculus, nothing. Hey, you just got lucky and guessed one of the candidates. There were 3 candidates, you had to find them all, choose the right one based on the evidence. That's why the answer is 4/3.
Put your double dot feature design for the 2020 dot. Simple is better. We cannot put detail in the feature.
Okay, would you get out 87B real quick and check your answers to 87B?
Design is selected and may be cropped to fit the parameters needed by our graphic designer. Senior high students, hop on your shade, grab your cooler, and dive on over to triumphantings.com. Come enjoy a classic soda fountain drink at the dance on Saturday, March 14th at 7 o'clock. Tickets are only $10, so be there or be square. National Honor Society interest meeting is in this fourth or during those hours. You should have received an invitation to apply if you are academically eligible. If you are unable to attend the meeting Friday 37th hour, please see this board for the application information as soon as possible. Late submission will not be submitted. Construction Career Hiring Event for graduating seniors on April 8th from 8 to 2 p.m. at the Denver Coliseum. If interested, stop by the Job Opportunities Board at the cafeteria.
Okay, moving down, 31 and 35 is 7 to 16-ish.
Please sign up with your math teacher. First come, first serve. Students should plan to attend both sessions. Bring your calculator and a
Okay, moving on.
junior high students. Middle school attendance starts Monday, March 30th. Practice will be at various locations throughout the week, with matches on Saturdays. We have all levels of experience, so beginners are welcome. Look for a flyer in your name. Hey Jack, it's time for your daily day of the day. Happy National Kids and Straw Day. That's all your announcements. Have a great day.
Oh. 87B is, then I do by the end of the day. 88, I won't have time to really, I haven't even put up the answers yet. So 88A is going to be due Monday. A and B due Monday. All right, now because I had the answers up here, and I want you to know if you did it well or not, but obviously I'm not going to have a lot of time for questions. So I'll grade 87B just based on effort. That is, just to be clear, that's my expectation that I'm getting a handful of people who say, I'm not good at these, so I didn't do it. Or I didn't understand it, so I didn't. It's never okay. I mean, there rarely, maybe once every couple weeks, there's a problem where I can imagine you not even knowing how to start. You should always give an effort, and it's not acceptable to just leave it blank. It's okay to miss it, that's calculus, but to not even try, that's not okay. All right? So, is it clear what Saul do? Yeah. I feel like I defeated you.
Yeah.
I win, yay! Me and calculus kicked your butt. Haha. Oh, no! We're all on the same team. It's a trick question. We're all on the same team.
No.
High school musical, baby. We're all in this together. Yep. Oh, super. I hope you did it. All right, so this is Monday, yes? don't have it labeled.
Exactly. And like if you
It'll be on my own. All right, good luck.
Thank you.
You're welcome. All right. This is good. All right. Thank you. Have a good weekend. Bye, Lily. No. Really? It's just a temporary setback. You'll be back in your groove in no time. I'm sure you're still on pace for a 5.
I don't know. I'm not really good. I'm not good at like longevity. I lose focus.
Oh,
after
ooh.
a while.
Don't do that.
Yeah, I don't know how I'm gonna stay focused the entire
You're gonna raise your game. You're gonna dig deep. Have a good weekend. Bye.
I sent a couple of emails in reply to your email.
Oh, super.
But one thing I'm going to just go ahead and ask if you happen to know now, because we're trying to do some calendaring things over lunch tutoring.
Okay.
This is saying we're doing our map testing during this modified schedule on April 20th and not around senior finals as we have in the past.
I thought there was a second page to this. Maybe I cut off the schedule. I think what you said.
I'm never real good. Maybe I just didn't click the sheet for that. I'm not real good with Excel. That's why I'm taking off a day in March to go to a district training.
It was formatted funky. Oh, you're right. It reads that
I
way.
don't see a sheet 2 down there at the bottom either. Because you referred to what we were proctoring or not, and I didn't see that.
Yeah, that doesn't.
Maybe I didn't go all the way over to the right. Pull your tab bar all the way over. I didn't go over any farther to say anything about proctors.
No.
Okay.
Yeah, that does seem to indicate.
Which it's not a huge deal for me one way or the other, and then you schedule the second day right after that for a worksheet plus finishing up whoever didn't finish the first day, since it needed more than one period. But some people have their IEGs tied to that. I do not. But people with IEGs tied to it may make a difference if it's a month earlier than they were bargaining on.
So I need to. Where is this in my meeting notes? Test schedule. So I need to. 420 map test.
Oh, thanks.
Not senior fund. Is that the question?
Yeah, because I don't know if they're going to do block days for senior finals or not. In the past, we kind of tried to incorporate it in there, and if not, it was still around that time. And like I say, I can make it work either way, but if I had my IEGs tied to it, I'd be nervous doing it a month earlier with that much less instructional time for measuring their growth on it.
Yeah.
And I also asked you in there, do we have verified placement testing dates?
Oh, yes, that we do.
I didn't put things in my calendar since they weren't verified. If you could send that as an email to all of us.
Yes, I will. I should have put that in there.
And then the other one was a budget thing that's just me.
Okay, thank you.
giving me anyone here that you lately work there for you. Okay? All right. Okay, go to lunch, buddy.